Yeah. Hello, I'm presenting my fog and edge computing project, a critical level multiple protocol IoT gateway for heterogeneous networks. In the next 5 minutes, I will demonstrate how edge computing can solve one of the biggest challenges in the IoT, managing devices with completely different communication requirements. Imagine a smart building with a fire sensor that absolutely cannot fail, security cameras needing a real time video, and thousands of battery powered sensors that must last for years. How do we efficiently manage all these different devices? Let me show you the problem statement. So, as per the IoT analytics, there will be and 75 billion IoT devices by 2025, and they all have different needs. A fire sensor must have 99.99% reliability. A missed fire alarm could cost lives, but it doesn't need to be fast. A security camera needs ultra low latency for real time monitoring, but it's plugged into power, so energy isn't a concern. A weather station running on batteries needs to last 5 years without replacement. So power consumption is critical here. Current solutions use one protocol for everything, which is like using a hammer for every job. It works, but it's not optimal. My solution, an intelligent edge gateway that automatically assign the best protocol for each device type. So this is my system architecture. We have different IoT devices in perception layer, and this is the internet. So, and this is the edge node running in the AWS instance, which assigns a protocol based on the criticality level of a device. And we store the data like reports and device assignment data into the S3 storage. So we will move into the system in action. So our current EC2 instance is running in the IP 3.94.167.248.242. So I'm going to connect. This is my local machine. I will be connecting to the EC2 from my local terminal here. Yeah. Yes, perfect. Now we are in the EC2. I just SSH'd into it. So first, let me check that all three network protocol simulations are running. I'm running it in Docker. So yes, all doc, all network simulation like LoRaWAN, Wi-Fi, and NB-IoT are running perfectly. And now let's run the gateway. So now the gateway, the Flask API is running. Great, the gateway is running in, and all protocol simulators are online. So now I'm switching to my laptop terminal. Now I'm going to run uh, a simulation, device simulation, which simulate 50 different IoT devices connecting to the edge. Now you can see first the devices, registering each devices, assigning protocols based on criticality, routing messages through the appropriate simulator like network protocols, and tracking performance metrics. So while registering, each devices will be declare its criticality like high critical low like this. So based on the critical level, the edge node will be assigning a different network protocols. So now it's running. Let's see the previous reports because it's consuming a lot of time. So the performance report and the device registration reports, both of them will be stored in the S3. So this is my S3 console. Here you can see there are some different folders like device assignments and logs and reports. Let's see the quick view on the reports. So this is the latest report we have been looking. So at the end of this simulation, we can able to the software itself generate a report which shows number of devices connected and the device data routed through different protocols. For example, NB-IoT has received a total of 5 messages with average latency of 366 and the average power consumption in milliwatt like 2.9328 milliwatts. So as like NB-IoT, Wi-Fi received 10 messages and the success rate is 80 and the average latency in millisecond is 8 and the average power consumed is 0.4. And the LoRaWAN, it received around 35 messages and the success rate is 91% and the average latency is 4103 and the average power consumed was literally 0.0091 milliwatts. So these are the performance metrics calculated by the Python edge node. So uh, the latency, if you see for the LoRaWAN, which takes long because it used the spread factor from S7 to S12. So the average latency is slightly higher than the other two protocols. In conclusion, let us see the project. Yeah, so we can see after and successful execution, the reports were being generated and it's populated to the S3 bucket. So in the conclusion, this project demonstrates that the intelligent edge computing can solve real IoT challenges by simply adding a critical level to each devices, which automatically get a maximum reliability where it matters the most, the minimum latency for the real-time application, and years of battery life for remote sensor. The key innovation is performing protocol assignment at the edge node, not in the cloud, reducing latency and bandwidth while improving the system responsiveness. The approach is immediately applicable to smart cities, industrial IoT, and much more. Thank you for watching. The complete code and the documentation are all available in the project repo. Thank you.